Yes, just
Yeah, you can start with the recording.
how the hell do I select the task? So I hope everything works. Yeah, it works. So is my screen visible?
Yeah, it is.
So the presentation is the talk sort of is about dying or the dying thing, like whatever you like to call dying in trust. Like does it represent, how to deal with it, and we'll discuss some of the things that it relates to in Rust and just the type system in general. So before we get started, about me, I work as a Rust engineer. I mostly work on.
Swarnim, sorry to interrupt. Can you just increase the font size a bit so it's more visible for some folks?
Is this more visible? Like better?
Yeah, I think that should be better. Thank you.
So, yeah, so I work as a Rust engineer. I mostly work with systems programming things, compilers, analysis tools, browsers, things like that. And I love to do graphics programming, game engines, and such things as well. So feel free to ask me anything with that. Other than that, I generally work with languages such as Rust, obviously, C++, a bit, like sometimes just for work. Uh, I'll, a bit more, I've started to pick up Zig and TypeScript as always, and I dabble in Haskell. So those are my interests. There are some other languages that I skipped, like Go, because they should be skipped. Just a sec, I'm zooming out my screen because if there's the QR code for the repo, if anybody wants it, you can just take a screenshot. Uh, I hope anybody who wanted to get to the presentation took the screenshot or something. The entire present, I will discuss some of the things about the presentation later, but this is, yeah, so I'm moving on. Hopefully everyone got the screenshot or something. Yeah, so, yeah. So for the presentation, so the first question that you might ask, what is Dyn? Dyn in Rust represents a feature of the language that allows us to do what generally in other languages people call dynamic polymorphism. And that's just the core of what Dyn implements. It just implements a hook for dynamic polymorphism because Rust in general doesn't allow for any form of safe dynamic polymorphism other than Dyn. You just cannot do safe polymorphism without the use of Dyn. And there's a reason for that. And we'll get into the reason later. But that's the core idea of what Dyn represents in Rust. So if you want a dynamic dispatch features like that, Dyn is there for you. But like you might ask, like what it really is in Rust, like what it is in specific context of Rust. And just to be clear, the slides is just going to be there to explain some theoretical part and some words and keywords that people may want to know. And then we'll get into a bit more code things so that we can actually discuss things and ask questions and discuss some things that will be much easier to deal with rather than putting them in slides. So yeah, so Dyn actually represents something called trait objects in Rust, and they are the only way to create trait objects as of Rust edition 2021. And you can find the link by just searching for bare trait objects and why they have been disabled uh, since version 2021, say edition 2021. And amazing. So I zoomed in a little too far, and oof. Yeah, back to where we wanted to be. Yeah. Yeah, so cool. But what are trait objects? Well, trait objects are types that allow us to define general behavior, but where specific actions are unknown until runtime. So like in general, when we are defining anything, we're actually talking about uh, behaviors in terms of behaviors. And when I mention behavior, I just mean a generalized mechanism to do something. Like, for example, if we say an animal likes to walk, so the walking is a generalization, and then we have a specific action of like some animals might uh, walk on the four legs, some on two, some in different ways. So the mobility aspect is the specific action which is not defined until runtime. It's similar to inheritance and whoa, my goodness. Yep. So yeah, so so this is a formal definition of what a trait object is and how it works. So a trait object just points to an instance of a type implementing specified trait and a V table. So it's just a table that matches the trait methods at runtime. So you can just look up for the trait methods at runtime based on what the type you actually have. And going ahead, so you can just basically understand this as the same as C++ overloading pretty much. And it's like overloading of data and similar things. Like you can just of it as interfaces. That will be a better explanation. So, but there's a major catch compared to how interfaces work in C++ and other languages. We shall get to that in the next slide. So let's just get on with it. And yes, so as you may have guessed, it's about safety. So yeah, so dynes are much safer than what you will generally expect from interfaces. And the reason for that is you can have like similar to how you can have version skew in front-end applications where your client and your server side can actually diverge. You can similarly have a skew in types when you have dynamic types or runtime types. So both the types that are when you have two parameters, for example, both the left and right hand side can actually diverge, and those sort of things are what the object safety defines, and that's how we get to be safe. Like safe as in Rust object safe, and there are some RFCs for it. You can search for object safety RFCs. They are like 255 RFC 255. I think was the first one, and then there was RFC 400 something, and a few others. So that's the link. You can just go to the link and figure it out. What are the rules for it? The rules for it are pretty simple. The trait needs, the rules for these are the rules for violating object safety. So like your type trait becomes your trait loses object safety. So like it's better to define rules which are less. So that's why I've defined it like this, because in almost every other case, your trait would be object safe. So the first one is where it depends on size. So if you one of the in your type trait when you're defining super type, if there's size in there, you don't get to be able to use it. And other cases are when you have another instance cell. So both have very specific reasons as to why they don't work. We'll discuss them later with code examples. That will be better. And so now you might think like Rust has impulse. So are they the same thing? Like are they the same? So here's a bit of a code example, and like we can see that it actually works. So like this code example will work. You copy and paste it into like some REPL or something. So the idea over here is we have a trait object and we are passing it through an impl. And impl just defines what something needs to fulfill, what conditions something needs to fulfill. And that's why trait objects always satisfy impulse. And that's why you can always use dyne with impulse, but not the other way around. So you cannot use an impl with a dyn because impl will always have concrete types. And if you want to pass them to dynes, you may or may not be able to do that depending on some certain cases. And another big problem with dyne is you actually need to be able to say that you can hold the type. So over here, what we have done is you have made it into a reference, and that's how we say that we can actually hold the type. And then the reason is 32 is a sized value. If I was using an unsized value, which is not directly implied by the bounds, it is working because it's not directly implied by the bounds, but it is feasible to build that value. Otherwise, you wouldn't be able to build that value because it would be unsized. You will need to box it. But again, we'll get into that later. How are the two different? I think we discussed that right now. So again, let's just skip that part and let's get to some code because presentations suck. And yeah, let me just do. Sorry. Before I start writing any code examples, like, does anybody have any questions? Like, what specific code example I should start from? Any confusions with dyne? Like, we can just start from there. And like, if anybody is not aware of some basic things about dyne, we can also discuss that while we are in the code view. So feel free to even put that in the chat. Senchin can probably tell me. So until you guys figure it out, let's just build a very simple dyne-based example of like the traditional inheritance examples. Yes, let's do that. So let's just iterate. And over here, what I've done is an actual implementation. So let's just not do that. Let's just say that the implementation, we don't provide a default implementation. So traits can provide a default implementation if you just write down an implementation here. But generally, you don't want to do that when you're defining bare traits because you don't have preconditions applied to your self type. And basically, you cannot do anything on your self type other than the default Rust things that are implemented globally. So it's not worth it to like implement a default type unless you can actually define the base constraints. Like for example, if I can say that std fmt debug, then yes, now what we can do is we can just say println. Now this code works and compiles and doesn't give me an error because now I've set a constraint. But if I just remove this part, then this will just fail and it will say that the self doesn't implement debug, which is quite obvious. So let's just get into writing a basic example. Let's just implement some structs. Let's just say a dog and cat. Like always, we enjoy implementing dogs and cats. So we can just say a dog barks and a cat purrs. So we now have very basic implementations for two structs. The structs are empty. So this is how you define empty structs if you haven't done that before. you can also define them like this, but sorry, you don't need this then. Yeah. So you can also define empty structs like this, but this defines how you will call the data constructor. And when I say data constructor, I just mean how you construct the type. So you can just say X is equal to dog over here, and this will work. But if I do this, then this will stop working. And the reason for that is now that this represents a struct type, and it represents an empty struct type. So the data constructor is an empty struct. So those are slight differences with how you implement these things. But either way, moving along, you now have cat and dog. So let's just do a function for, sorry, this create a function called pet animal, and what we'll pass it is animal, which will just be a animal, and all that is required is animal dot speak. So you pet an animal that speaks. Very simple. Every game ever has implemented this, and we can just implement pet animal on X. And we see some issues. So the first issue that we see is it says that expected a reference and we found a struct, which makes sense. So we'll just give it a reference. Does this work? Again, it says it doesn't work, right? It says it doesn't work. It says it doesn't work because even though the function has been implemented, we know that this function is not implemented through the string. So like this is an interface and we don't implement that interface, and that's why this doesn't work. So all that we now need to do for dog is say an animal for dog. So this is how you implement a trait, and that's done. Now our code compiles, and we can just quickly check that if it does, card will run. Like if you can see right next over here, it just says bark. Right. Senshin, is the screen visible, or should I zoom in a bit?
Yeah, it's visible for me. I'm not sure if anyone else has issues.
I just made it a bit bigger, and let's just put the cursor at the top and just run this command again. Again, it should be visible. Let's path. And again, now if you just try the same thing with cat, it won't work. And again, now again complaints that animal is unsatisfied. Same issue. Animal, even though the function exists, but animal is not satisfied because it's the specific trait that this trait object requires is not implemented. So these are closer to a functions than a structural thing, which Go implements. So hopefully now we have a good base to go on, and like I've covered, if even for people who didn't understand know the basics of how trait objects work in Rust. So if there are any questions with the basics of Rust trait objects, just let me know, and we can just try running this. And yeah, we can pet a cat and it purrs. So yeah, that's it. And now, so do you have any questions? Yep, doesn't seem like there are any questions, so we'll just move on. And in our slides, we discussed that dynamics need to be object safe. Okay, so now we'll discuss a couple of things and how to write dynamics, how to make them object safe when we probably think we won't be able to do that, and when we can do that. Like when you can make something object safe, And when you can't make something object, there is something that you need to understand in some cases. So let's just go ahead and try to how do we make something unsafe first? Like that would be a better question. So let's just implement a function. Let's say, so we can just implement get like to the most simplest function I think is get, or you can just do let's just do a get for now. It should be simple enough. You do a self and self, and you just return and self, and you can see that it is broken. So this is an easy way to just break your object safety, and it just explains and it points to the same traits object safety documentation that I had linked in the slides. Also, I think I think the presentation slides are not available. Let me make sure that they are public. Is this public? It's not public. Oof. Okay, I will make this public in a bit. But just drop down the link for it. So this should be public by after the meet's done. But either way, we have broken object safety, and we can see that it doesn't work anymore. So how to get it working? Like you often will have cases where you would want to do something like this, and you would think like, how should we fix it? So there is a very simple way to fix it, or like it's sort of a hack in some sense. Like you can do actually you can do a lot of things to this. And over here we can say again it's broken, but you can do T, and you can do T, right? And now, what is the other case where it's broken? Yeah, okay, good. Like it gives us an entire description of the same issue. So we can just quickly click on this and see what the yeah. So all super traits need to be object safe. Size need not be size cannot be a super trait. It must not be associated. It not have associated constants. Associated types with generics. So basically, this is how we broke it. So this is an associated type now, and not really an associated type, but an associated function, but with a generic. So anytime that you use generic and start returning them, that will be an issue. And you can just say self where self something like sized as well. Again, this will be also be an issue. So most of these implementations where you are manipulating with types in a weird way will be cases where you can say that type safety will be broken. And we have now a get function. So we'll just implement a get function. But like if we can't do that, what can we do? So that will be what you would be thinking. So if we move it to T and then we return T, then it's object safe. And the issue now is that it's object safe, but now you need to provide the T, right? So now the interesting thing is that if you can statically provide it a T, then it's fine. But if you can't provide it a static T, then you'll still have the same issue. You cannot do an impl over here. So, for example, if I say animal T and I just say dog, then this works. And we can just do fn get and self dog. And we can just implement cat f, sorry. So as you can see, I'm just returning a new cat and dog, but what you should do is actually just do self works. Now, because you can see that this works, but that wouldn't have worked over here. Because like if we just try and do this, this doesn't compile. So the code is practically the same in both places, but now this requires code duplication for us to not worry about object safety. And the reason for this is we cannot guarantee that the types will match over here. So we cannot guarantee that the type of self and T will be the same. And the moment you try to guarantee that, like if you just say it will be an animal, something like this, then you end up with the same issue that you used to have. Like you can't do this, right? You can just recursively put in types. So again, the fix is pretty simple. You just need to have a type that gets uh, affirmed before the type for the trait is created. So in simpler terms, whenever you see that something needs to be object safe, you can just lift up whatever things that you have that you want to return. And that's how you can do the same thing. And then you can implement it something like this. But again, now this will add specificity to your type. Like this animal can only now return a dog. So how to handle cases where it's more flexible? So there are a couple of ways to do that. But the best way is coming in nightly, and we don't have that yet. But if we install nightly, we can just see that. Let me just quickly exit out and we'll just move to nightly. That's a fault. Yep. It's a couple, like it's roughly a month old nightly version, but should work nonetheless. So now what we need, or like what we want to do is, we should just say impl t, right? So because we say that impl t, okay, yeah. So for now, this won't be allowed. Like, let's just do a better example for this. Also, just to be clear, self will break over here as well. Like if you use. Now, as you can see, this over here is going to destroy, like, again, it's going to make the thing object unsafe. And this will stop working. So currently in nightly, we have the ability to do this. Right? So again, this still hurts object. Wait, what? Yeah, so this will still hurt object safety, as you can see, because we are directly resolving two animals. And in these cases, the simplest way to do this, something like this, is to move this get function out and create a trait animal extension. and now you can implement it. And if you have used Rust, you probably have seen a lot of extension functions, and this is the reason they exist. And oh, sorry, I missed something. Uh, like you just need to ensure that all the super types cannot be what do you call it? Object unsafe, but all the any of the subtypes can be object unsafe. So this doesn't break the invariant of object unsafety. And now you can finally implement it for animal. And the only function that you actually have to remove is get, which you can then impl animal extensions or cat. Okay, some cats. Okay, mistake. Yeah, so now you can use animal or animal extension, both work. And impl is a nice way to get around trait safety. So if you were to use animal extension over there, and the reason is this won't work. Like if you want to just take in arbitrary arguments and simplify your code, and if you just want to call something that animal extension already has, there will be problems with using this, and the reason for that is can be made into trait object. So yeah, so impl is the way to get around it, and we can use impl because we are on nightly, and I have everything enabled by default, and we don't have to include them. Yeah. So again, it just says security requirement for trait has extra. Oh yeah. So this should be an extension. So now this is now this doesn't need to exist, but yeah. So the steps for always improving your object safety is to build extension traits. Extension traits can help you resolve all your object safety concerns downwards, like push your object safety concern downwards. And you can just separate out functions that are going to require you to make code object unsafe. And this is also helpful when you are writing unsafe traits. So another very good use of this is to write unsafe traits. So now this trait, animal extension is unsafe, but the trait animal itself is safe. So people can use the animal trait without having to get into the weeds with unsafe traits. And unsafe trait is useful because now if you're implementing it, now you need to now write an unsafe implementation. And this ensures that now you can easily catch bugs because now you will be careful, at least somewhat more careful when writing code like this. And you won't have to pollute your normal animal trait with all the unsafe things. And the second thing is you should always try to use impl if you want to have some form way to not depend on object safety in your traits themselves. So the problem with generalization generally becomes that you would not get object safety, hence you will have to generalize in a more complicated manner. So impls are a better workaround. Again, they're only available in nightly at the moment for traits, so that's a bit sad, but they should soon be added to stable, and that's it. So if anybody has any questions, we can discuss that, but otherwise that's it.
Yeah, there was one question on can you please explain the difference between address dynamic animal and impel animal?
Yeah, I think we didn't probably discuss that. Yes. So yeah, so over here we have a pet animal this, and we have let's create two functions. I'm audible, right?
Yeah, you are audible.
animal impl. And now what we can do is we can just say impl. So now this is going to force both of them to do the same thing. And this is just going to be on animal. So this, like, let me just simplify the code. Let me just remove all the extension things so that we don't have to worry about that. Yeah, so this works, and we can just do this. And yeah, so as you can see, Dyn and impl both work, and they both work fairly well. There's no issues whatsoever. And you can see that the correct code will get called. We can just quickly ensure that the correct code is called carvar. You can just see that per is being called twice. So now, till this point, Dyn and impl seem to be the same, and there are minor differences which are very specific, but for greater majority of things, they are going to seem to be the same. But the concern or the problem starts because impl requires your types to be well defined at the source position, whereas Dyn doesn't require that. And that's a big benefit that Dyn provides over an impl. So a good example of this would be if you like a good example of this would be when you would be using something that is that won't form the same type but is being returned from the same place. So Dyn is more useful at return position rather than input position. Again, it has a lot of uses in input position as well. Like for example, let's just take a case here. And let's just make this pet animals. All right. Similarly named function. Okay. Yeah. Oh. And we're just going to comment this one out. So we now have A and B, both are actually the same things. And we can just quickly do a cargo sh and it will work. Now, the thing about impl is, again, it will work fine. Even if I add this animal simple, we can just make this. Yep, we now need 2 arguments and we can just provide the same. Yeah, so same thing. And we can just comment this one out and run this. And again, it works. So now the thing is this will work. And this is the reason why it's more useful in the return position rather than the argument position. Because whenever you're passing something in the argument position, generally you already have a fixed type. And you're not going to be changing the type. So that is one thing that we generally know with a fact. But sometimes you might not actually know a type. And the concern is you will already have a type when you're passing it over here. So your type will already be a type. So let me think of yeah, let's just reverse this example. That will be much easier. So let's just say fn get animal. So what we are going to do is I'm just going to use a box. I'm just going to use a box because it's easier for me and everyone else to not have to worry about where the data storage is going. And that just helps us not worry about anything else either, right? So we can, we can just say cat. So a box new cat works. And what we can do is we can just say, we can just take a flag. Let's just say, is, so we can just say cat bool. And if cat and we can then just write dog. So this code works. So this code works, but now let's just do the same thing over here. Let's just do a get animal function, and let's just keep the cat thing, and just rather than doing a box line, let's just do impl animal, right? So now the moment we do this, we see an issue. So, and just to confirm, like if I just remove this, and this. Oh yeah, sorry. Get animal into. Yeah. Yeah. So currently it just says that it doesn't implement that. So in these cases, it's sort of easier to use something like FN because all the things are auto implemented over there. With box, you will need to implement that on top. So like a better example of this is just returning cat because we are not defining a box on top. So if we do impl cat, this will work, and we can just remove this and just say dog. And, now the issue is cat and dog both should actually work as return types. They don't, and the reason is pretty simple. Because now basically it says now you need to do a box type, as you can see, and the reason for this is the types are different. So now I think we are getting to a proper explanation. So an impl is what defines your type when the function is being built. So you can think of the compiler when it sees impl, it will just build your function twice or like 3 times, like whatever number of times it requires for all the types that you're trying to put into that function to be satisfied. But it will generate a one viable definition for a specific set of types. But over here, even though the types are not changing, so without a change in types, we have a change in the output type, which should be fixed at compile time. Whereas dyne is where the types are not fixed at compile time. So these are dynamically reset. That's why you can put in this sandbox. And just to be clear, we can actually, we don't really need to put any of this in box. We can just do yeah. So this currently says it doesn't work, and the only reason for that is that. I need a type specified static. Yeah. So I've cheated a bit, and there are some extra concepts now over here. But I just wanted to prove that this doesn't really depend on the concept of boxes. This only depends on the viability of dyne versus impl. So they're as close as we can get them. We can actually, I can even send a static reference over here as well. And we can just have a reference. We can have a reference. And it won't compile. The exact same code and it won't compile. And the reason for this is the type needs to be finalized. And it says the type that was expected doesn't match. And the reason for that is this dyne specifically is a type, and this type exists even at runtime. Whereas impl never exists at runtime. It will always be finalized into some type. So that is basically the answer. what the difference between dyne and impl is. Yeah. So I think that was it.
Anyone has questions for Swarnim that they would like to ask?
So
Okay, if there are no more questions, thanks a lot, Swarnim, for giving the talk today. It was quite useful, especially the last part of the difference between dyne animal and impl animal. I think would help a lot of folks. Yeah. So thanks a lot, Swarnim, for the talk today. Thanks for everyone who joined. And we also recorded this, so I would make the recording available in maybe 2-3 days. Yeah, thanks everyone for your time.